section 3.1 of Melham's Math 120 online at CSM. Okay, so in section 3.1, we'll be talking about something called functions. So there are several definitions of a function on page 152. Function is a rule that pairs each element in one set called the domain with exactly one element from a second set called the range. So the set of input values is the domain, set of output values is the range. In order to have a function, each element in the domain goes to exactly one element in the range. Alternate definition on page 154. A function is a set of ordered pairs in which no two different ordered pairs have the same first coordinate. The set of all first coordinates is called the domain of the function. The set of all second coordinates is called the range of the function. So for any given x coordinate, there can only be one possible y coordinate in the relationship. And on page 156, a relation is just a rule that pairs each element in one set called the domain with one or more elements from a second set called the range. Alternatively, we could say a relation is just a set of ordered pairs. In the xy plane, it would just be a set of ordered pairs x and y. The set of all first coordinates is a domain. The set of second coordinates is called the range. We have something called the vertical line test for graphs. It's on page 157. Vertical line test. If a vertical line crosses the graph of a relation in more than one place, the relation cannot be a function. If no vertical line can be found that crosses a graph in more than one place, then the graph represents a function. Here are some examples of functions. Okay. For each of these graphs, if I draw a vertical line anywhere, it will touch the graph in only one point at most. So they are considered functions. Normally, when you have a function, you can isolate the y. So notice y is isolated in each of these. Y equals absolute value of x minus 4. Y equals x squared minus 4. Y equals 2x plus 2. Those are all examples of functions. Okay, so let's take a look at the homework now. 3.1. The homework is 1 to 31 odd on page 159. So here are some questions. And some more. More. Next page. Page 160 looks like. 20, 21, 22. And we had to go up to 31, so I believe you can see up to 31 there. Now for the answers in the back of the book. Section 3.1. There's some of the answers. A bit more. There. Okay. So for each of the following relations, give the domain and range and indicate which are functions, right? So the domain is a set of all x values. So for number 1, the domain would be the set consisting of 1, 3, 5, and 7. The range would be the set consisting of 2, 4, 6, and 8. It is a function because there is no x coordinate, first coordinate, that is repeated. Number 7, the domain is just A. You have A, and A. So the domain is only A. The range is 1, 2, 3, 4. Since there's a repetition of the A, we do not have a function, because in order to have a function, an input value or an x coordinate A can only have one possible y coordinate, but A matches to 1, 2, 3, 4 different y coordinates. So this is not considered a function. Okay, for these, we just see, does it pass the vertical line test or does it not pass the vertical line test? So number 9 is a function. If I draw a vertical line anywhere, it touches only one point. Number 11 is not a function because if I draw a vertical line, let's say right over here, it's going to touch in more than one point. Okay. 13, the circle is not a function. It's possible to draw a vertical line which touches at 2 points. But 17 is a function. If I draw a vertical line anywhere, it's going to touch in only 1 point. Determine the domain and range of the following functions. Assume that the entire function is shown, right? So for 19, the domain, the x values go from -5 to 5. So it would be from -5 to 5. And if you want to see exactly how it's written, you can look at the solution set. And for the range, it'd be going from 0 to 5, including 0 and including 5. For 21, the domain is from -5 to 3. Look at the solutions and how exactly to write that. The range is just the number 3, just a simple number 3. And finally, how do you graph these? Well, we can just make a chart. So graph each of the following relations and use the graph to determine if the graph is a function. All right, so 23, y equals x squared minus 1. I just made a table of values. Let x go from, say, -2 to 2. If you plug in -2, -2 squared is 4. 4 minus 1 is 3. Plug in -1. -1 squared is 1. 1 minus 1 is 0. Plug in 0. 0 squared is 0. Subtract 1, -1. Plug in 1. 1 squared is 1. 1 minus 1 is 0. Plug in 2. 2 squared is 4. 4 minus 1 is 3. So I plot the points, -2, 3, -1, 0, 0, -1, 1, 0, 2, 3. Looks like this. It is a function. It looks like it passes the vertical line test. The domain is all real numbers. The way you can write all real numbers is with this funny looking R. Okay, so any x is allowed. Okay, for the range, y has to be greater than or equal to -1, or you can write it in interval notation like so, bracket, -1, comma, infinity, and a parenthesis. Okay, bracket means include the -1. Parenthesis means you don't include that particular number. Infinity and negative infinity always use parentheses. Right, 22 looks almost the same as this one, but x and y are reversed. It says x equals y squared minus 1. And if you stop and think about it, all that happens is x and y are reversed from here. So why don't I just take all these values and just reverse them? So that's exactly what I did. I just took all these ordered pairs and reversed them. 3, -2, 0, -1, -1, 0, 0, 1, 3, 2. Okay, so for instance, if you plug in -2, -2 squared is 4, 4 minus 1 is 3. And likewise, suppose I plug in y is 1, 1 squared is 1, 1 minus 1 is 0. Okay, but essentially, I just reduced this to reversing all of these 5 ordered pairs. Okay, and if you plot these, 3, -2 is here, 0, -1 is here, -1, 0, 0, 1, 3, 2. It looks like so. And this does not pass the vertical line test. I can draw a vertical line which touches at 2 points. So this one is not a function. All right, and for the domain for this one, it just reverses what happened over here. So I can just switch these around, so to speak. So for the domain, I'll abbreviate domain with D. It's bracket 1 to infinity, and the range is all real numbers, like so. Okay, 29, y equals x plus 2 squared. Okay, so I first plugged in the same numbers from -2 to 2. Okay, if you plug in -2, -2 plus 2 is 0, 0 squared is 0. Plug in -1, -1 plus 2 is 1, 1 squared is 1. 0 plus 2 is 2, 2 squared is 4. 1 plus 2 is 3, 3 squared is 9. 2, 2 plus 2 is 4, 4 squared is 16. Okay, so if I just plot those points, I get this, -2, 0, -1, 1, 0, 4, 1, 9, 2, 16. Okay, in reality, the graph actually keeps going up like so. So we would plug in -3, -4, it would end up looking like this. Okay. It is a function. It does seem to pass the vertical line test. Okay. The domain is all real numbers. So x can go as far to the left and to the right as you want. The range, the lowest y value is 0, including 0. So 0, comma, infinity. You can go as high as you want. The lowest y value is 0. So the range is bracket 0, comma, infinity. All right, so these are notes for section 3.1.